Well, my friends, today I bring you a research performed by some people in Aalto University in Finland, which is called the researchers use quantum mechanics to see objects without looking at them. This article relies on a very interesting property of the quantum war, where the connections are so sensible that a very tiny and infinitesimal change can be even detected. But at this time, they did not perform this research by using the light. As you know, everyone sees using the light. You people, any person see because they have a portion of light which is getting the eye, and this portion of light is captured and translated, and somehow you are unable to interpret what you are seeing or what is in front of you. So if there is not light, if there is darkness, people doesn't see. So this is the typical concept of watching. And based on this, we settle the uncertainty principle, which is relying that if I want to see an object which is very tiny, based on the wavelength that I'm employing in this light, I will perturbate the system. So I will have an uncertainty, because if I want to see the position of the particle, of the tiny particle, I perturbate it because I'm sending a portion of light. And if I perturbate it, I will not see the velocity. I can see the position, but not the velocity. But if I want to see the velocity, I send a less energetic wave, but I will see the velocity and not the position. So this is the uncertainty principle settled by Heisenberg, which is not so intuitive, but it's the reality. At this world, which is very tiny and where the quantumness is present. The point is that this researcher, they are a group of 3 researchers which are highlighted. They are Shurtri Dogra, John McCord, and George Parawanu from Aalto University. They make somehow an adaptation of the Nobel winner prize, which is Anton Seilinger, which is the Nobel winner this year. This research, for the first time, he settled the rules for running the interaction-free experiment, where you are not, you are diagnosing a system, but you are not, let's say, touching it, or you are not using any kind of touch or a portion of energy. But by the other way, you are somehow detecting what is coming from the system which you want to diagnose. So you are not perturbating the system that you want to watch. You are simply getting what is coming from this system and try to interpret what is coming. So the thing is that these people change the typical paradigm where the optics is employed for watching the system. In this typical system, you are using the laser and mirrors to understand and to see and to measure what you are interested for in the system. Okay? You use the optics. Based on this concept, you perturbate it probably. This guy rearranged this concept, and they use a detection to detect the microwave. So instead of using the mirrors and lasers, they use the microwave and superconducting materials. To this end, they use the transmon. And the transmon is a kind of circuit which is very sensible. It's a kind of large circuit, but even this, it has a quantum behavior. And using this property, they were enabled to detect very low pulses of microwave and with a high efficiency. At the first time they run the experiment, they noted this and they said, okay, there is something here that we need to pay attention. They went back, they reanalyzed the statement, and they could achieve the objective of saying, okay, what is happening here is real. So we are going to run the experiment again, and they were able to prove that the detection of the very low pulses of microwave is possible by using this kind of arrangement of superconducting material based on transmon. And the point is that when you use a transmon, you have a system where the quantum coherence can be controlled differently because you are incorporating this transmon. So there is a certain time where you have three particles interacting in this coherent time. Yes? And as this is happening, you are enabled to detect finally, efficiently, the microwave pulse that is coming from the system you are watching. So they are using the concept of quantum coherence, taking advantage of this, because it gives you the possibility that an object can occupy two states, but you don't know what is the state of the object. You cannot watch indeed, because it's several stages at the same time. It's like the law of probability. At the coherence time, you have a law of probability. It comes there, it comes here. The point is, when this wavelength collapses, you finally see, okay, what I have is here. So applying this quantumness level of the transmon incorporation, you just can say, okay, I measure the microwave using the quantum coherence concept in this new arrangement that surprisingly does not incorporate light. So it's a very, very efficient, according to what they proposed, what they said, is kind of very efficient setup, because it's detecting very low pulses of microwave coming from whatever that is sending microwave. This is the best of it. I have a sensor of microwave, and much more better, this is not altered because of the light. So it's very interesting experiment that these researchers perform. So I wanted to mention this because I think it's not so intuitive concept, but the thing is that this is science. Not intuitive things are watched every day. So if you have different point of reference, you can see probably what is true and what is not. So the point is that we just try, let's say, to emulate what these people made and try to understand what is science and what is happening around us. Interestingly, this is based on the concept of interaction-free experiment. Keep in mind this, interaction-free experiment. So they modified this to employ the interaction-free protocol. And standardizing this protocol, you apply it one time, second time, third time, any kind of times, and you get the result. How you see this result? This is up to anyone. But the result is what I said. We can diagnose systems that emit microwave pulses, very low potency microwave pulses. So, well, I invite you to keep in touch, to keep following the content that we are offering. This is initially for everyone. You just try to keep pending and be careful about what you say, how you understand the system, because they are kind of very complex things, but not necessarily. So if you have any doubt or something, feel free to contact me and ask me. For sure, I will try to answer as soon as I can. See you. Keep on touch. Ciao.